Okay, hello students. This is a practice problem. Practice problem. Lesson number 17. I think the last time when I did 16, I think I made a mistake. Let's try do it one more time. The problem one. The first problem was x squared uh, plus 0.5x minus 14 equals 0. Okay, now there's a point 0.5. Okay, you can use we could use this and get the answer because there's a decimal there. But we can also do one more thing is we can write this half as half 0.5. We can write it half and then multiply all the terms by 2. So multiply 2, multiply 2, multiply 2, and you end up getting 2x squared plus 1x and 20. Now this we can easily factorize. Let's check how. Because 2 times this is negative 28 and negative 28 we can split as what our option is 1 and 28, 2 and 14, 3, 4 also go there, 4 and 7. Out of this there's a minus, so one of them has to be plus, one of them has to be minus 1, and at the same time you should get plus 1 when you subtract. The only one that you can think of, uh, oh, 2 times this is not 20. I think it's 56, so it's not this. So let me clean this up. Okay, I thought it was, I just took 28. It should be 2 times negative 28 is 56. So how do I split this 56? So what are option 1 and 56? Then we have 2 and 28 that we have seen. Then 3 doesn't go, 4 goes. So 4 times 1 and 4 goes. So that's how you get that one. And I think you can think of 7 and 8. And you can see this is the one when you subtract gives you 1 because there's a 1 here. But then what do we take? Because you need to get a plus 1, I'll use plus for the 8 and minus for the. So then this will give you plus 1. So the best is write this as 2x squared plus 8x, then minus 7x and minus 4. And then we can use undo distributive property. You can see there's a 2 which is common for both. 2 is a factor, x also. So when you pull out 2x, you get just x by itself and plus 8. Now in the second case, you can clearly see there's a negative 4. So if this is negative 4, we write negative 4. And this number is 28. Okay, I'm sorry. So 7 is pulled out, and what stays inside will be x. And now this minus sign which you see, this minus will switch to plus. And 7 goes 8 times, so this becomes 8. So the reason is to switch is because if you use distributive property, you should get back the one before. And then you realize that now you see this, there's a x plus 8 here, and there's x plus 8, which is a factor for the 2x and 7. So we can easily, so this is equal to 0. So we can write, okay, x plus 8 is a factor, and what stays is 2x. So this 2x will stay, and then there is minus 7. So this is how you get equal to 0. And by using zero product property, one of the factor has to be 0. Either x plus 8 has to be 0, or you can say 2x minus 7 equal to 0. And by subtracting 8 both sides, you end up getting x equals 8, and you add 7, 7, and then that's how you get, see, if you divide by 2, it's 7 over 2, so, and you're done. So there are two answers, so your solutions are 2, 8 and 7 over 2. You could also write this as 8 and 3.5. So, in other words, the graph is like 1, 2, 3, 4, 5, 6, 7, 8. It goes through this, and 3.5 maybe here, and you can see Negative 14 basically means the graph uh, is okay. So this one is -8, so I missed that minus. That means this goes to 3.5, and on -8 it will be minus here. And you will see there was a -28 that we got here. What that means is somewhere down here is -28. So the graph goes through this one, something like this. And somewhere it goes down, takes a turn, and then it, this is the graph of the one that I did, the second one, this equation. Okay, but the one that you see is this one. This will be different because this is goes to -14. What that basically means is, if you go deeper in that, -14 is maybe if this was minus half it, so this is how it is. So it is going to go through this, okay, like this. So this is the graph, okay. But the one that we shown here is 2x squared, which is vertical stretch kind of two. There was a two there, and that's why you see it gets stretched here. This graph gets stretched. So this point goes here. So anyway, that was not the question, but I'm just sort of showing this. Let's see if there was another. You could also use this using zero product property, like, okay, this is x squared plus 0. No, I mean quadratic formula. And what is that is? So you can use x equals minus b plus minus square root of b square minus 4ac and divide by 2a. So you can, by looking at it, a is 1 and b is 0.5 and c is negative 14. So this is what you do first, and then you plug it in here. This a will go here. This b becomes opposite here. It's plus here, but now it's going to be minus 0.5. So you can do it this way also. So this is 0.5, the whole square, minus 4 times the a is 1, so the a is 1, and times c is negative 14, divided by 2 times 1. So you end up getting x equals minus 0.5 and plus minus. Now this will be negative and negative, with this negative and this negative 14, and this 4 times 4 is 16, that will be 56. Okay, so you get this point is 0.25. So that's 0.5 times 0.5 is 0.25. This together will be 56. So this is 56.25, and then divide by 2. So this is 0.5 plus or minus, and this is 7.5. See, and you work it out two different ways. One with minus 0.5 plus 7.5 divided by 2, and the other one is minus 0.5 minus 7.5 divided by 2. And you see this is 7 over 2, and this is 8 over 2. And this will be negative 8 over 2, which will be negative 4. Okay, so I hope that helps. But the one that I did before, maybe I made a slight mistake. You can check it. But this is the right answer. One is negative 4 and the other one is 3.5. Okay, so this is how you can do two different ways. There are two solutions. Let's go to the next one. Okay, look at this problem here. This is the second problem. I think we can think of, I want you to think is whether it is it a perfect square. And how do we know it is a perfect square? The best thing is look at this number 12 and take a half of it, and that answer becomes 6. And then that one you square and you get 36. Okay, and this 36 right here, it means this is same as writing 12x plus 6 square. And we can write down this is the form a square plus 2ab plus b square equals 0. And we can write it as a plus b the whole square is 0. That means your a is x, so x, and the b is 6. 6 the whole square is 0, and you're done. It means it is x plus 6 is plus minus square root of 0. Means x plus 6 is 0, and if you subtract both the side, you get x is 6. What it means, there's only one solution, 1, 2, 3, 4, 5, 6, where the graph, the parabolic shape will touch here. So that means if I put x is 0 here, this goes away. You can see this is the y-intercept somewhere here. Maybe this is 36. So the graph is like this. Okay. So there are two solutions, 6 and 6 repeated. So it's a one solution is repeated, so we say this the x equals 6 is a solution, or is a 0 with multiplicity 2, because its x is, so this means x is 6 and 6, so multiplicity 2, so it just touches, so one solution but repeated. Okay, this is problem number 3. So let's see. Now, what do you think? What method do we use here? So the question is, do we use completing the square method? This is one method we can use, or quadratic, or factoring. Okay, so we have to decide. Now, let's see, can we use factoring? Can we split 8 into, like, what are the factors of 8 is? We can think of 1 and 8, and 2 and 4. Now, there's a plus. That means when you add 8 and 1, you get 9 and you get 6. But this one is 3, so this will not help. I think the best of bet is a quadratic. Because even if you try to use completing the square method, and you see you want to complete, like, if I want to write this by subtracting 8, and this will be negative 8, and then what is the constant to be added so that this becomes a perfect square? So the problem is there's a minus 3, and if I want to make a half out of this, okay, and then there is a fraction does not go with the denominator too, so if you square, you get 9 by 4. Okay, which is actually 3. You can use this, okay. So when you do this, that means this side it is 3 over 2 square, and when you add, you have to add both the sides. So that way, you can use, let's go on with this, and then we'll see which other option is better. And you can see this is like a square minus 2ab plus a b square. And that becomes so complicated. So there's a minus, so put a minus, then this is the b, the whole square. I mean 3 by 2 equals, this is 9 by 4, so this is 9 by 4. So you times 4 and divide 4 to get the same common denominator. And these two pieces will be minus 32. And from here you take away 9, because there's a plus 9. So you get 23. So that becomes 23 here. Because, okay, and then you want to get away with the square, so you'll have to put a square root both sides, but here, so it becomes so difficult. So you get x minus 3 by 2 is plus or minus square root 23. Now you can separate this radical for both numerator and the denominator, and the square root of the denominator 4 is 2. Okay. So the two answers are, you can go on doing this and you get the answer. So what? Okay, let's check. Let's really do that. So you get x minus 3 by 2. First time you put plus, okay, and then when you add 3 by 2, and I'm add 3 by 2, so you get you get 3 plus square root of 23 over 2. Remember, the thing is, you're supposed to figure out the mistakes, and the mistake is, watch this, there's a minus 32 and this is plus 9. So this should be minus 23. So if this is minus 23, so this is minus 23, this is minus 20, all this is minus 23. It means, other words, you have the equation becomes 3 plus square root of 23 I divided by 2 divided by 2. So there is that I complex number. So this means there is two complex numbers for this. Now this became a little confusing because there's a fraction. What if we had to do quadratic, and that becomes easier? Let's see why quadratic becomes the easiest. So here A is 1, so that's A. B is minus 3, C is 8. So when you apply the quadratic formula, so let me do that, make a room for me. So x equals minus b plus minus square root. That's the quadratic formula. And let's plug it in, minus b. So this is b, and there is a minus. So you just do the opposite of this, which is 3. Then the minus 3 is square. Then minus 4 times a. A is 1, so a is 1. And c is 8. Divide by 2 times 1. So let's do the radical part first. Then see what's going on there. This becomes 9. And this becomes 4 times 8 is 32. So 32 take away. So there you go. We get that same thing, minus 23 and divide by 2. And now you can write this as x equals 3 plus or minus root 23I. See? Divide by 2. And then you write two answers. So one answer is x is 3 plus root 23I. And of course, you have to separate this just to show the real part and the imaginary part. And the second time, 3 over 2 minus. So there are two complex roots. So this means basically the graph that is the equation means there's a parabolic shape which is maybe this way. It is going this way, and it does not cross the x-axis. So there are no real solution. And you can see main thing is that you get under the radical sign is like a discriminant. This is also called discriminant. So whenever the discriminant is negative, you will see there will be always two complex solution or roots. I think this is a quadratic is the best option if it cannot factorize. And completing the square method is easy only if this number is even. If it is odd, it becomes difficult. I hope that. Let's do the next. So you have x square plus 4 is 0. So you can see there's a linear term missing here. So linear term missing. What that means is it means it is 0 times x, right? So such cases you can use square root method. And what is square root method? Square root method is you just get the constant on the right side first. See? So you get x squared is negative 4, and then you take the square root. But when you take the square root, you want to make sure it is plus or minus. So then this will be x on the left plus or minus square root of 4I. But we do know what is square root of 4, which is 2. So the two answers is x is 2I, and the other one is x equals minus 2I. So both complex. So these are called complex roots, two solutions which are not real. In other words, you do know that what is this actually? It's a parabola. If this is the original parabola, then this graph is, when you put x is 0, you get 4. That means it moves up. So that's the parabola like this, which goes through 4, and it does not cross the x-axis. See? So that's why there are no real solutions. No real solutions. So I hope this helps. Let's go to the question number 2. All this almost 20 minutes I spent only on the question number 1, which has sub questions A, B, C, D. Okay, look at the next one. You are given x squared plus 7. Again, we will use square root method. So first And get the constant on the right side, so you get x squared equals -7. Then take the square root both sides. So when you do this, remember you have to put plus and minus. And the reason is if you have x squared is b, then x is plus and minus square root of b. So now this and this goes away. It means it is x. So your x is plus minus square root of 7 and then I. And the reason, again, I'm repeating one more time. It's this way. It's 7 times -1, which is square root of 7 minus 1, and that is square root of 7i. So you get two answers, one with plus and I, and the other one is both complex, two non-real solutions. See? So there's a bottom, there's a D, which will say you get two answers, and both answers are not real. They have a imaginary part, and that's it. Yeah, sometimes they ask you to write this in the complex form, standard form, which is a plus b. It's like 0 plus square root of 7i, and the other one is x equals 0 minus square root of 7i. This is another way to write, and you're done. So remember, and how does the graph look like? So this is the graph 1, 2, 3, 4, 5, 6, 7. See? And it does not cross the x-axis. There is no real solution, and you're done. Now remember question number 4. I don't. This we have been doing all this while. Remember when you write 3x plus 2 and on the right side is minus 16. Remember there is a plus here. You can't have plus and minus on either side whenever there's a square root. So we say in such cases there is no solution. It means the graph here, you can see if you try to write this has to be inside the radical, has to be greater than 0 or equal. And if you try to solve, you get minus 2/3. Now where is minus 2/3? This is -1, maybe this one, and the graph is something like this. See, this is the this part square root function, which is this one. See? Let me use below. This is the square root function, and so there are two equations here. One is the square root of 3x plus 2, and the other one is y equals minus 16. It means 1, 2, 3, 4, 5 like this, and if you go on and then minus 16 is here, there's a line. So this line and the graph, they never cross each other. So there is no solution here. So question number 4, what they gave you is the first three equations, they gave you three graphs, okay? Now look at this. This is the very first one, right? You see this? So you already given, there's a 7, it means it goes through 7. Look at this, the y-intercept. And you can see there is the graph goes through these 2 points on the x-axis. That means there are two real zeros. I will call them zeros. You can call them solution, two real solution for this. I want you to check this with another one. The same thing you see here also. What does this basically means? It means there are two equations. The first one is x squared minus 6x plus 7. And the graph that you see is this one. This is the graph. And then there's a minus 2. What this means is y is minus 2. This is a horizontal line. So this is a horizontal line through 2. So I'm using the color here. Watch this. So the 2 is here. And you can see they are like this. And it touches at one solution. So there's only one point where they touch, cross. And then we say, okay, there's only one solution. Of course, here it is 3. So it may be this is 3. So 3 comma 2 here. So when it is 3, it is 2. And so there's one real solution. So first part is, you see, the first one had two real solution, okay, two real solution. But this one, you have one real solution. That's what they are checking on you, whether you understand that, please. Now I'm going to use the second one here, not the second one. Let's see, the one that has minus x squared, and so that minus x squared is 2 times. That's minus x squared is right here. There's minus x. These two are the same thing. So we'll see the graph of this. Let me stop. Okay, look at this. So this one is minus x squared minus 3x plus 2. Now this graph, this is the graph. It goes through somewhere between -3 and then takes a turn somewhere and goes down. So there are two solutions. One is here, so two real solution. Okay. This, but the second one, there's one more they gave. I don't know. Is let me check one more time. If you see this, no. Okay, so some they will ask you maybe I don't know. This is what this equals to 0, and suppose they had to give you x squared minus 3x plus 2 equals let's see 2. Let's see it was 3. Then you will see there will be a horizontal graph going through. See like this. So still you are going to get two real solution. But what instead of 3, if they had to give us minus minus 3 here or minus 4. And what does this mean? That minus 4 is this line horizontal, and you can see still crosses, right? But what about still two solution? But what about it if it is more than maybe here 7? So this 7. So this is y is 7. So if I put 7, then you will say no real solution. I mean no solution at all, not even called. So then nothing. We say just say no real solution. So if they give you like this, then you can always say there is no real solution. Maybe it means there are two. Maybe if this was 7, so it goes like that. So you say it does not cross the graph. So we can say no real solution, but you can say two complex solution. So the rest of the thing you can complete yourself. So this will help you for the package 16, 17, and at the same time to complete Unit 3 tests. I hope I wish you all the best. Bye.